Okay, Lecture 7, Significant Figures in Calculations. You should know the definition of exact number. First question, which of the following statements include exact numbers? There were 35 cars in the parking lot. Now, an exact number is one that you come up with when you count items or when you define units of measure or relationships between units of measure. So there were 35 cars in the parking lot. You went out, you counted them. Since it was counting, 35 is an exact number. Now in the sciences we say you always hear there's nothing that's certain. There's nothing that is exact. So if we say that there's exactly 35 cars, there must be some uncertainty, and it's what we define as a car. Those 35 cars, all of them are different. Even if they're the same make and model and year, they'll have some differences between them. But if you look at all the range of cars that are in the parking lot, there's a huge range of cars by size, shape, color, mass. So that's where the uncertainty lies, is in what we call a car. There were 35 gallons of water in the tank. Well, gallons is a volume. To determine that volume, we had to do a measurement. So this would be inexact. It's a measurement. A bunch of bananas had 7 bananas in it, so you had to count them out. 1, 2, 3, 4, 5, 6, 7. That's counting. That's exact. So 7 is an exact number. A bunch of bananas weighed 5 pounds. Weighed tells us that we did a measurement. If you did a measurement, then it's inexact. You didn't count out the 5 pounds. It had to be weighed. You had to measure it. There are 100 centimeters in 1 meter. So 100 centimeters equals 1 meter. That's a definition or a relationship that you set up between centimeters and meters that's exact. And in reality, we could write it like this and show that there's no end to the precision here. We know the relationship between centimeters and meters out indefinitely. We wouldn't put the bar here and just showing the zeros, but you put here. There's an endless number of zeros because it is exact. So both of these numbers in this definition are exact. Now, let's see number 2 here. Find the answer for each rounding to the appropriate number of significant figures. So we have division here. For multiplication and division, your answer is going to have as many significant figures as the measurement in the problem that has the least number of significant figures. So your first number here has 6 figures. Now these are measurements, so they should have units of measure, but traditionally what you do is you leave the units of measure off so that you don't have to worry about them. And they just clutter things up, but these are definitely measurements, and this is 3 significant figures. So 18 divided by 6 is 3, and it's going to be zeros, but how many? So 6 and 3 here, so we already have 1 significant figure, so that's where we stop. For addition and subtraction, we go by the number of decimal places, the least number of decimal places. So we have 3 decimal places, 2 and 1. So this would be 3 again, just by chance, same as the above answer. But here we have 1 decimal place. That's where we have to stop. Now for both of these, you might ask, why is it that we have to do that? Well, if you look at the first one, we have a huge amount of information here. This measurement was done out to 4 decimal places, but this one was only done out to 2. This has a huge amount of information. This doesn't have as much. So when you divide this very precise number by one that's less so, we have to go with, our answer has to have less precision because we've lost some information. Same thing here. Let's say 3 different people measured out a block of wood and found it to be 1 foot on a side, but one measured out to a thousandths place, 1 to hundredths, 1 to tenths. Even though this guy did his amazing job of measuring this block of wood out, this guy didn't do such a great job. And so the information is lost. We have to go with this, because since this guy only measured to this point, we don't know what these numbers are out here. Same with this guy here. So we have to stop. The next couple of numbers might be 3, 4. This might be a 7. That could change things drastically. We can't. So we don't know what happened out further because the measurement wasn't made as precisely. When we have addition and subtraction, multiplication and division all mixed up together, well, we have to do the them one step at a time, and here we put parentheses around addition and subtraction so that we do those first. And so let's do them out. Do this out first and round. 1.567 plus 3.11, and this is 4.6770. But since we've added, we have to go out only to the third decimal place. So we stop here. So our answer is 4.677. And then we have on the other side 6.9870 minus 4.0473, and we get 2.9397. Both went out to the fourth decimal place, so we get to keep both of all those digits. Don't have to round. And then we have 4.677 times 2.9397. So this is going to give us a lot of numbers. 13. Make sure it stays on the page here. 13.748969. Can't leave it that way. That's really, this shows you just wrote it right off the calculator. We have to do the rounding. We have 5. Now we're to multiplication. So 4 and 5. We have to go with 4 significant figures. So we have to stop here. Now it's 4 and it's followed by an 8. So by our rules from the textbook, we get 13.75. We have to round up. And now, when you're doing this, you do out each different operation, you have to round as you go. It's by the rules of propagation of error. Sometimes you see in textbooks that they say, well, just wait till the end. That's not the way that it should be done. If you do it without rounding and get to the end, you might end up with the same answer, you might come close. But whenever you change from operation to operation, you have to round before you continue on. This last one here, we have 7.8811 divided by 5.555. So this is 1.4187, 39874. Normally you don't have to do this, I'm just going to show you. So we have 5 significant figures in 4, so 1, 2, 3, 4. We have to stop here. Now that's a 7, it's greater than 5, so we have to round up 1. Minus, and then we have on the other side 1.1556 times 3.152, and we have 3.6424512. 5 significant figures, 4, so we have to stop here. This the last digit, after the last digit, the one that we aren't keeping is less than 5, so we don't touch this number, 3.642. So check the rules on rounding. But that's wherever we're going to cut off, we look at the next number. If it's 5 or greater, we round up 1. If it's 4 or less, we leave it alone. And you'll see in some books a little more involved rounding rules. Do whatever it says, but in this case, for this class, this is what we use. Okay, and then we have minus 2.223. They're both out to the third decimal place, so that's our answer.